Hello, this is Renee Robinson, and I'm here to teach you how to do a simple grams to grams stoichiometry problem. I am pulling this problem from Modern Chemistry, the book you see in the top left-hand corner, number 4 on page 287. The problem reads, when sodium chloride reacts with silver nitrate, silver chloride precipitates. What mass of silver chloride is produced from 75.0 grams of silver nitrate? So in this problem, like every stoichiometry problem, first things first, always make sure that your balanced chemical equation is as it needs to be, balanced. Or your chemical equation needs to be balanced. So here we start off with sodium chloride, then we reacts with silver nitrate to produce silver chloride and sodium nitrate. And I can tell based on looking at it that this is a balanced chemical equation, so we are good with that. Alright, from there, we always, at least I always, look at what is given to me in the problem and what it is that I am trying to find. So in this one, I am trying to find the mass of silver chloride, and I am given the grams of silver nitrate. Alright, with that said, we always start off with what's given to us in the top left-hand corner. And this is going to be the longest stoichiometry problem, so I'm going to try to give myself some room. We'll see if I can fit it all in there. We start off with our 75.0 grams of silver nitrate. We need to cancel grams of silver nitrate, so we'll go ahead and put that down here. Grams of silver nitrate, and again, like I stated before, every time we have grams, that is using our molecular weight, and we have 1 mole of that same compound on top. Always 1 mole when you're using grams, whether that grams is on top or bottom, always going to have 1 mole of the same compound. And this number is our molecular weight we pull from the periodic table. Here we have 1 silver, 1 nitrogen, and we have 3 oxygen. Oxygen is 15.99. I like to use 16, should be about 48. Nitrogen on the periodic table is 14.007. And silver is 107.868 grams per mole. When we add all of that together, 107 plus 14.07 plus 48, we should get 168.875 grams for every 1 mole of silver nitrate. And that number comes right up there with 169.875 grams of silver nitrate. Alright, now that we have our grams of silver nitrate, they are canceled, which is good because we're trying to get to grams of silver chloride. Alright, now we have moles of silver nitrate, so we need to put moles of silver nitrate on the bottom here so we can cancel them. And this is that transition stage. We are transitioning from what is given to us, they're the compound, the compound that was given to us, silver nitrate, to the compound that we are trying to find, silver chloride. And it'll always be what's given to you on the bottom, what you're trying to find on the top, in mole to mole. And we pull these from the balanced chemical equation up here. If we look at both of these, they are both 1 mole. So we go ahead and put our 1 mole there, which makes life easier. Alright, we've canceled our moles of silver nitrate now. Now we have to go from moles of silver chloride to grams of silver chloride. So we're going to go ahead and cancel our moles of silver chloride by putting that on bottom. And we need to get to grams, so we'll go ahead and put grams of silver chloride on top. And just like this step over here, this step's very similar, just grams are on top over here versus on bottom over here. So always 1 mole, like I stated, whenever you're using grams, it's always 1 mole of that same chemical formula or same compound. Always 1 mole when you're using grams. But we use the molecular weight. We have silver and we have chlorine. Silver again is 107.868, and chlorine is 35.453. We add those two together, we get 143.321 grams per mole. So that's how much one mole of silver chloride should weigh. And when we put this all the way up here, 143.321 grams of silver chloride. We have now canceled our moles of silver chloride, and we have grams of silver chloride on top, which is what we're trying to find. So that's how we know we can stop our train tracks for our stoichiometry problem. And in our calculator, we would put 75.0 divided by 169.875. These are both 1, so you never really have to put these in a calculator. Then we multiply that by 143.321, and my calculator, which should be correct, it would be 63.2763, and it kind of goes on forever. But if we look on our problem, we notice that there are 3 significant digits that were given to us. Remember that this 0 counts only because of that decimal. So it would be 1, 2, 3 significant digits. So our answer should also be given in 3 significant digits. So we're going to round this number to about 63.3, since this 7 will make the 2 round up, grams of silver chloride. And that is your answer. Now remember, these grams to grams stoichiometry problems are really interesting because they really contain all of the stoichiometry problems within them. If you're looking at a mole to mole problem, that's these 2 steps, without this one, of course, but you're starting off with the mole, then we go use our mole to mole transition step. If we're going from moles to grams, we take that one step further right here. If we're going from grams to moles, that's all of this step. And if we were going grams to grams, it's obviously the whole thing. So, grams to grams stoichiometry, very simple. Thanks for watching.